Okay, grade 11s. This is question 2. It's another vector question. This question is coming from November 2020. Yeah, this is November 2020. So if you go to the internet and look for November 2020 on this website, www.acexams.co.za, you'll get this question paper, grade 11, November 2020. This is question 2. So it's also another question on vectors. So let us read the question. They said a pulley system is used to keep a crate of mass m kg stationary as shown in the diagram below. So this word is very important, stationary. So this system is stationary. Also you have 3 vectors here. You have T1, you have T2, and then you have M. So imagine you have something like this. Three vectors that are acting at a point. That's T1, that's T2, and that's M. They are stationary. And then before you go to the questions, just try to do yourself a closed vector triangle as I showed you previously. A closed vector triangle. So remember, a closed vector triangle, we call it a vector diagram. So your vector diagram in this case will look something like this. Will look something like this. So you have T1 going to the left, that's T1, and then you have T2. You see T2 has that angle, but if you do your normal line here straight with M, you'll discover that this is a 90-degree angle. So if this is a 90-degree angle, that means this is 60. So that is 60 degrees. So if you do take this vector M and you extend it, like you extend it upwards, this is that vector M, you extend it upwards, and then next to vector M you have this T1, that is T1, and then you have that T2 here, which is 30 angle here, then 60 degrees there. In other words, to close this vector triangle, we have to take T1 and put it up here and close it like this. That is T2. We didn't change the direction of T2, so this would still be your closed vector triangle. 60 plus 90, that's 150, then you need 30 to be 180. So that would be your closed vector triangle. So you can do easily like that. So then you can take out everything that you don't need. So that is a closed vector triangle in this case. So you can label it. So that's T2. This is T2. Sorry, this is T1. So that is T1. So that is T1. Okay. So this is T1, this is T2, and this is our M vector. We don't know the magnitude of this, but I think for T2, they told us T2 is 245. So this one is 245 newtons. So we don't know this one, we also don't know for that one, but we do know all the angles. So let's go to the questions now and let's read the questions. 2.1, define the term resultant vector. Define the term resultant vector. We've already defined that one previously. We said a resultant vector is the vector sum of two or more vectors. So as long as you mention that term is a vector sum of two or more vectors, that's the definition for a resultant vector. And then we go to 2.1. Calculate the horizontal and vertical components of T2. Okay, let's go back to T2. T2, here is T2. Here is T2, is that vector. Now they say this vector has a horizontal and a vertical component of this, which is correct. Here there is a horizontal vector, which we call it Tx2, and then there is a vertical component of that, which is called T2y. So we need to find now the value of Tx2 and Tx2 and T2y. Alright, so you have something like looks like this. That is T2, which is 245 newtons. Imagine you have this now, x, let's call it T2x, and then the vertical, we will call it T2y. So the angle there is 30 degrees. Look now for this value and that value. Okay, let's create a space. Okay, let's do this calculation quickly. So T2x is equals to f cos of theta, and then T2y is equals to f sine theta. So what is f? Is the magnitude of that force or that vector, which is 245, cos the angle will be 30 degrees. Then we will do that one. Okay, let's take the calculator and see. Let's check. You have 245 cos of 30 degrees. So you have 212,18. So it's 212,18 newtons. Now let's look for the second one. You have T2y, which is 245 sine of 30 degrees. So this one, 245 sine 30 degrees, that is 122,5 Newton. So these are the two. That was 2.2.1. So these are the answers for 2.2.1. Let's see if we can take this here. Let's say we want to take this from here Okay, let's undo that. Okay, so I'm gonna paste this answer here. Next to down below this one. Okay, yeah, so that is 2.2.1. We have done the calculation. So let's go to the next question. 2.2.2, calculate the magnitude of T1. 2.2.2. 2.2.2. 2.2.2. Calculate the magnitude of T1. Okay. Now we want the magnitude of T1. Okay, let me redraw this just a little. The magnitude of T1. Remember, let's say we have a vector diagram that looks like this. So this is T2. This is T1. And this is M. So we said this is 60 degrees, this is 90 degrees, and that is 30 degrees. This is 245 newtons with two components. Now, I'm going to do something here. Remember, this force now, this vector, which is T2, has that horizontal component, which we call Tx1, and then it had the vertical component, which we called T2y. And then let me make a space here. So remember, Tx1 was 212,18. 212,18. This one was 212,18 newtons, and this one was 122,5 newton. So these were the values. So because of this, M block is stationary, so that means that this vector now going to the right is equal to the vector going to the left. So T1 in this case is equals to Tx1, which means T1 is also 212,18 newtons. And this M, which is going down, is equal to M is equals to T2y, which is 122,5 newtons. So we've already determined the magnitude of these vectors because of the system is stationary, the system is not moving. Or let me make this more interesting by making calculations just to give you the benefit of the doubt. If you want, you can also do this. You can use the sine rule here for T1. You can say T1, let's use a different color. Let's use this one. You can say here T1 over, because of T1 is a side that is looking at this angle, so it's looking at sine of 60 degrees. We do know this side, which is T2, so T2 is looking at which angle? Is looking at that angle, so we can say T2 over sine of 90 degrees. And then you can make your calculations here by saying T1 over sine 60 degrees is equals to T2, we do have the value is 245 over sine of 90 degrees, then you can cross multiply. T1 sine 90 degrees is equal to 245 sine 60 degrees. Then we divide by sine of 90, we divide by sine of 90 degrees. Then we can cancel sine of 90. You have T1 is equal to 245 sine of 60 degrees all over sine of 90 degrees. Then you take a calculator, then you can check that you have 245 sine 60 degrees. I think sine of 90 is 1, so we can still punch it. Sine of 90, which is okay, because if I think sine of 90 is 1, I know that one from school. So this is sine of 90, the amplitude is 1. This sine of 180 is 0. The sine 270 is minus 1. So sine 90 is 1, that one I know. So it's 245 sine 60 degrees. So we can just punch that one. 245 sine of 60. Check the answer. 212,18. 212,18 newtons. So it's true that T1, this value T1 is 212,18, similarly to Tx1. So these two are the same, they are equal. So we prove that by calculations that they are equal. So this was the answer for 2,2,2. So I'm going to take it here, then I'm going to paste it here. So I'm going to paste it down here. Let me take this one out. So let's delete this one, paste this one. So that is 2.2.12. They said you must calculate the vector T1, so we did find T1. We did get T1. So this is the calculation for T1. Now I don't know why it doesn't want to paste now. Yeah, this is 2.2.2. That was the calculation for T1. So the last question now, the last question, which is calculate the mass M of the crate. Mass M of the crate, that was 2.2.3. Mass M of the crate. So let's find quickly that mass. The mass now, 2.2.3. Remember, we use the formula, the weight is equals to the mass times G. So we need to know what is the weight of M before we can calculate the mass of M. So can we find the weight of M? Remember, I said now M is equal to T2y. M is the vector that is going down. So this vector M is equal to the vector that is going up, which is T2y. If T2y is 122,5, that means M is also 122,5 Newton. Let's prove that by calculation quickly before we continue. So let's say we have something that looks like this. That's T2, that's T1, that's M. So I'm going to use a Pythagoras theorem here. According to the Pythagoras theorem, imagine this is a y. Imagine this is a y. Imagine, okay, this is a X, okay, yeah, this is the X, this is the Y, this is the R. So Pythagoras theorem says R square is equals to Y square plus X square. What am I looking for? We're looking for Y. So I'm going to put Y on the other side. I'm going to put R square minus X square on the other side. Then Y is going to be equals to R square minus X square. Now in this case, what is R? R is T2, which is 245. So I'm going to put 245 squared there minus what is X? X is T1. Remember, T1 is 212,18 newtons. So I have 212,18 squared. So let's quickly punch this in the calculator. Remember, Y now is M. Y is M. So let's check this in the calculator. So we have 245 squared. Okay. We have 245 bracket. Okay, let's put the square root first. So we have the square root of 245, close the bracket, you square it, minus 212,18, close the bracket, square. Look, the answer 122,5. 122,5 newton. So our assumption was correct that M is equals to 122,5 because Ty is also equals to 122,5. This is 122,5. 122,5. Here is it, 122,5. So we know now the magnitude of M is 122,5. So let's go to our calculation here. So the weight of M is 122,5 equals to the mass that we want multiplied by 9,8. Okay. Let's continue with the gray color. So we have 122,5 equals to M times 9,8. So we divide by 9,8, we divide by 9,8. Then we get the value of M, divide by 9,8. 9,8. The mass now is 12,5 kg. So that is the mass for the block. So I think, yeah, we have come to an end of our video. There were only these few questions. Okay, I'll see you now in the next video.